is that this one here, this is 120 coming into the inverter board. Has a fuse on it. If that fuse bad, your compressor run? No. But if that fuse bad, you might have a problem with the compressor windings as well. This one here is the communication. This one here is going to connect somewhere back to this main board here, and it's going to be told, hey, turn the compressor on full speed, the fridge too warm. Hey, slow the compressor down. So this voltage here is converted by these components, and then this plug right here is sending the power to the compressor, making it run. So, I'm sorry, I hit my elbow on the screen. So, which one is it? I don't even see the, where's the program? It completely closed on me? I lost.
Maybe you hit the X.
I hit it with my elbow on the screen. I didn't even touch. It's, I think it's this one right here. I don't know what happened to it. It completely just closed out. We'll just have it open back up. We'll go back to where we were. So, going back to what we're doing is got 120 coming in here. There's just a low voltage frequency coming off of this board telling the inverter how fast for the compressor to run. We can ohm out the compressor from this board on either one of them. But, I mean, if you're already back there, the compressor is right there. Because if I went here and I tested the compressor and didn't get a reading, I would still have to go to confirm that my compressor, you know, that the wires were connected and the wires were good. So if I'm in the back, I could just check the compressor. Now, someone asked the other day about the voltages coming out going to the compressor, and you can't really tell the voltage coming out because why? Yes?
It's variable, so it's AC?
It's variable, so we have a frequency and we also have AC voltage, so it's not just voltage that makes that compressor run. The frequency is also what tells that compressor to run. So you would have to actually use hertz to measure it, and we'd have to go to the tech manual and say, well, this thing at high speed is going to run, let's just say 240 hertz or kilohertz or whatever. Then you'd set your meter. What you have to do then is go into diagnostics and force that compressor to run at full speed. Then you can check the frequency going to the compressor. And you would know if your board's outputting the right frequency. You couldn't check it during normal operation. You'd have to go into diagnostics, tell it to run max cool, and the board will the book will tell you this is the frequency it's supposed to be running at, and that's how you can match it up.
How would you
Go ahead.
How would you narrow a problem like that down? Like that sounds like the customer will tell you it's not cooling 100%. How would they know?
Well, not necessarily cooling 100%, but what if the customer tells you, I have no cooling, right?
Yeah.
And you want to know, is the inverter board sending the voltage to my compressor? You know about your compressor, all your pins send right.
Mm-hmm.
Well, how do you know if your inverter is telling the compressor to run or not? Because could the compressor be mechanically bad and not running?
Yeah.
Could it have a restriction or something? So ohming out a compressor, does that tell you that everything's okay? No. You could have other types of problems. But if I know the frequency coming out of here, know what it's supposed to be, and it's right, my problem is not electrical with my computer system. Because this is the only thing, and this one talking to it, is what tells my compressor to run. So as long as I measure that output, and it matches my computer boards, I don't have a problem with. Now I have to go, my compressor's probably bad. Even though it ohms out. You could have ohms good, mechanically bad. You had a question?
How much volts is at the speed on the compressor?
The voltage change. That's why we want to check frequency. Frequency, we can actually go to a manual, it tells us what frequency is. Okay? So I wanted you to see when we looked at the one refrigerator versus the hub refrigerator, that all of these boards that were in that one refrigerator, they're all built into this one refrigerator board here. Okay, now these boards apparently have the Bluetooth and the Wi-Fi built onto the board. They're not separate boards on the side, which I thought they were. Someone told me that's where they were, but that's not it. So you guys understand like the different parts of the board? You have another question?
What's that blue box right there in the middle, on the second,
This
second
one?
one? Nah, on the second screen.
That?
Yeah,
That's not a box. Actually, there's an opening on the board right there,
yeah.
and they had it laying on like a blanket,
Oh.
and I cropped the outside of it, but you can almost see it through the little holes
Okay.
where the screws are. That's just the blanket it was on when the picture was taken. That's nothing.
Oh, okay, okay.
That's nothing. So, again, I'm gonna put together another slide for the GE refrigerator, for the Frigidaire refrigerator, for the Whirlpool refrigerator, and we're gonna compare all the boards, because if you can identify what this is on the board and what this is on the board and what that is on the board, even if you don't know how to test it right now, at least you know what the different parts of the board do. So then when you go to your diagram now and you're seeing all these wires coming off the board, you have an idea of where those parts are. Any questions on them? And I'll show you guys that refrigerant flow on that one refrigerator. Let's see, I think I have it here. Thanks to Ms. Ward, who got me this diagram off of another refrigerator. I call it technical support. I'm not going to throw anybody under the bus, but I was used to seeing a step valve. A step valve would be a valve located right here between the capillary tube and the suction line. It would be right off the capillary tube here.
That's like a little white box or something like that, like a.
It has a plastic thing over it. It has 3 capillary tubes on it. And this would go to the step valve, and that step valve will send Freon to one or the other evaporator. But this refrigerator didn't have a step valve. And then when I looked at both evaporators, the capillary tube only went to the evaporator in the refrigerator compartment, not the freezer. Usually when you have a step valve, you have a capillary tube on this one, and you have a capillary tube on that one. And the valve will say, okay, send Freon to the freezer. No, send Freon to the refrigerator. You know, but in this case, how are these evaporators plumbed together? They're in series. So when the Freon comes from the capillary tube, it goes through the refrigerator, then goes through the freezer. I know they're upside down, that usually the freezer's on the bottom of a French door. But it goes here first, and then the arrow says it goes to the freezer next, and then it returns back to the compressor here. So one of the guys in the class was working on the Samsung in the class, and he said, wait a minute, I turned this refrigerator on, and I wanted to see the frost pattern on the evaporators. And this one had frost on it. He says he touched this one, it was room temperature. And this is why I was calling the guy, because I said, wait a minute, if they're in series, that means Freon flows through this before it gets to that, but it flows through both. Whenever the compressor's on, Freon's running through both. So, you know, how is it this one's getting cold, but this one is room temperature? And the only thing I can come up with, because the technical support guy couldn't really explain it to me, is I'm assuming the compressor is running so slow that it only filled enough Freon into this evaporator. And that Freon, by the time it left the evaporator, was totally evaporated. What that means is it came in the capillary tube as a liquid, it leaves as what? A vapor. When we see that capillary tube change from a liquid to a vapor, that's what we see the frost on the evaporator when that Freon's changing pressure. If we have no change in pressure here, or not pressure, but in temperature here, that there was no frost on here, all we had to do is speed the compressor up, put so much Freon in here that very little evaporation is going on here, it's all being done in this evaporator. And the only way he could tell me, oh, if you want to see both work, go into diagnostics and put it on fast freeze. But I said, but that doesn't explain to me why that evaporator was warm. So I still don't see it in the tech manual that explains, well, that's how it works. But that's the only way I can figure out how those two evaporators will work. So when it puts Freon into here, if the compressor is running so fast, it will start turning the vapor here, but there's so much Freon in here. It's what Evelio said, is that it might be what we call a flooded evaporator. It has so much refrigerant in it, it's still not evaporating. It's maintaining mostly liquid state in here. And by the time it gets to the second evaporator, now it's starting to boil off. We still have some evaporization here, I would assume, but not like if we slowed the compressor down and only put Freon into one evaporator. Yes?
Can you eliminate the step valve?
There is no step valve on this.
Oh,
The step valve would take this and put Freon there and back, or Freon here and back. In some refrigerators, it opens up to both evaporators. In this case, this goes in this evaporator, out this evaporator, in this evaporator, out that evaporator, but it comes here first and goes here second before it comes back, always. It's just how much refrigerant do I put in there. What does a leak look like on a refrigerator? When we look at an evaporator and we have a leak in the system or we're low on Freon, what do you see on the evaporator?
like
Cross
a
pattern?
sheet, like a sheet of ice.
What did you say?
An incomplete frost pattern?
Be a little more specific. What do you mean by incomplete frost pattern?
Wherever the leak may be, you may not see frost at all.
You
You
might
may
see
see
a
frost
little
on half
ball
the
of ice.
evaporator, or the back half of the evaporator, or the front half of the evaporator, depending on where it's at.
It's like a ball of ice in one spot.
Usually you'll see your ice where the capillary tube enters the evaporator, and then maybe 1 or 2 rows from the capillary, not the back, not the bottom, whatever, wherever the capillary tube goes into the evaporator is where we're going to see that frost pattern. If we're low on Freon, the rest of the evaporator would be what? Warm.
Warm, and it wouldn't have any.
You guys look at that little simulator that we have, and it runs, only the front rows freeze and the rest are room temperature. Isn't that the same thing happening here? That there's not enough Freon to fill both evaporators? The only way to do that is either take Freon out or slow the compressor down so it doesn't fill up the second evaporator.
The first.
Well, the second one. I'm saying that when if the compressor is slow, the first one freezes, but by the time it leaves there, it's warm, and that's just like the simulator.
The phone turned off.
It turned off again?
Yeah, it did.
All right, well, that's done with that. But so that evaporator will freeze this one. Well, all we do is speed the compressor up, and then both will freeze.
So if you can't speed up the compressor, what happens if you overcharge it instead?
Well, you can't charge by pressure. You can't charge by pressure. You have to charge by volume. On a variable speed compressor, the only way to know if it's charged properly is you'd have to do 2 things. You'd have to go into diagnostics and force the compressor to run at maximum speed. Because if you charge it and it's running on a slow speed, what happens when the compressor speeds up? Pulls into a vacuum. We don't have enough Freon to feed both. So you have to go into maximum speed, and if you have a step valve, you'd have to, I think with Whirlpool, there's a way to open the valve so both evaporators are open and getting Freon. Then you can check the pressures. Yes?
So after thinking about it, this fridge can only cool 1 compartment at a time. Would that be correct?
It probably could pull 2 if it's running about 3/4 speed. It's not gonna be
One
max
evaporator has
efficient.
Okay, that's what I was asking.
You're not gonna have maximum efficiency. So like you just bought the refrigerator. We're gonna run this thing at max speed
Because your fridge is more important.
and try to compensate, or 3/4 speed so that both evaporators have Freon in them and have evaporization going on. And if the air by each would have their own separate fan. When the refrigerator reached temperature, that fan would shut off. The compressor speed could change to force more Freon into here or less Freon, depending on which area we want. But that's why on any system that has a variable speed compressor, you can walk up to it and check pressure, come back the next day and check pressure, say, wait a minute, yesterday I had 0 PSI, now I'm 10 inches in the vacuum. Well, when you charged it, was the compressor running full speed? Because maybe it's running full speed now and it pulled it into a vacuum. You cannot go 100% by pressures on a variable speed compressor. The only way you could do that, diagnostics, and go into max speed by diagnostic with any refrigerator. Because max speed is going to give you the pressures you're looking for. The 0 and the 142 on this one. Does that make sense? Because if it's running slow speed, you're not going to have the pressures. You might not have enough Freon in there, and it looks like you're running in a vacuum. The same thing with a step valve. Depending on how fast the compressor is running and which evaporator is getting Freon, you put your gauges low and high side. What are you checking? You don't know. You don't know both evaporators or one evaporator. This one here, there is no step valve, but you still have to run max speed to get your pressures.
Super cool.
So I guess the most effective way to test would be just recover everything and then measure back in.
Well, not to measure it, but if you thought you had a sealed system problem and you just said, well, let me add a little more Freon to top it off because I thought I had a leak. No, the best thing to do is recover what's in there and recharge based on what the model and serial number tells you to do. That's the only thing you can do on a variable speed.
Right?
This is 134 because it tells you that you're running at 0 PSI. Where
600 for
600, I think, runs at about 8 PSI.
Yeah, 8 PSI, 6 PSI. But believe it or not, 0 to 1 is acceptable. You're just losing, I think they taught us like 15% cooling.
Well, the problem is if you don't have enough Freon in your evaporator, then you're using a small evaporator. Imagine taking a wall air conditioner and put it in the wall that cools this room, and then you go and say, oh, the air conditioner broke, but I'll borrow this one, put it in there, and you went from a 24,000 BTU to an 18,000 BTU. That unit's going to run all day and don't feel like it's cooling in here. Any questions on this, guys? I didn't really plan on talking about this, but I've been calling and researching and trying to get all this information together for you guys. So once I get the next refrigerator and I go through the board and I get information, once I got it all together, we'll talk about the next one. Okay? All right. Go back to work then.